This is an alternative approach to getting your link-based queue implementation up. In this case, your collection is a circular linked list, which means at the end of the queue, it links to the front of it. You're getting rid of this pointer that signifies the front. Let's say if you were to in-queue something, add to the rear, but you're going to be performing at least 3 operations to server this connection, adding 1 node to it, and have this node points to the front of the queue, as well as adding this rear of the queue to the new node, and then pointing this rear all the way here. For DQ, you'll be getting rid of this, ensuring that the rear queue points to this. You eliminate the use of the front pointers. Let's move on. The complexity analysis here calls for storage operations. So the storage size for both array-based and link-based are pretty similar. Remember that the array-based calls for the upfront allocation of the fixed size of the elements that you need. And that is the only unknown, because sometimes you don't know what you don't know. If there's going to be sufficient space, or simply there is way too much space pre-allocated for array-based implementation. The link-based implementation, however, does not require any more space than necessary. So all you need to do is to have an empty link list to start with as your size of the queue, starting with 0. The total amount of the storage allocation depends on how many elements you have in the link base. Operational efficiency, both are O of 1. And the reason this is O of 1 is because we have both front and then rear. This is the front and then rear. Adding something to the end of rear or deleting something pointed to by your front is O of 1, because you already know which part is the front, which part is the rear. Now, if you don't have front and the back pointers, you're going to have to do O of 1 in order to find out the end of the list. That is very, very cumbersome. So typically we have both front and rear. Both operations are O of 1. Same thing with the array base. As a matter of fact, these pointers for array base is just index, front index and the back index. For linked list is the physical node that points to these front and rear references. Array base O of n in the linked list does not require anything to start with. The special case consideration is array unbounded queue. Unbounded queue requires an enlarge method. Every time you need to double the size of your array, here is the added cost. This does not include in storage the need to do O of n copying. It's costly considerations. This is a pictorial summary of what it looks like when a queue is represented by a fixed size array, as well as by a link-based array, where you have both front and the back for both array-based and MyQueue. The difference between the two is the front and rear here is represented by index, integers. These front and backs are the node itself. This allows you to point empty object, a label for the front, and an empty object, which is a label for the rear, both pointing to the physical node. But this has a drawback. You have to specify a fixed size to begin with. When we're dealing with pre-allocation of memory without knowing how many elements that we have, that's just not a good idea. You don't want to over-allocate, you don't want to under-allocate. Linked list implementation is the much preferred methodologies.